lot of times you can bring in a competitive
It crashed.
I like his actually.
Okay, howdy. Oh, hi. So, okay, so there are two announcements. So no quiz today, and exam result will be posted on the next Tuesday because I have some students who need to take a makeup exam. So I just, yeah, if they can take it in the Friday, then maybe I can upload it in the, in this weekend. But if not, then I need to, postpone it to next Tuesday. But I try to deliver it to next Tuesday, possibly, right? Okay, great. And is there any other question? No? Okay, then let's start the new chapter, chapter 16. Oh, okay. Do you have a question? Who's speaking?
I think her mic is just on.
Oh, okay, got it. Okay. So do you have any question or not? Is everything good? Okay, so then let's start the chapter 16. So in this chapter, we will learn what the identification number is and how can you find some, generate such an identification numbers and how can they find some errors on the identification number. So the identification number is like your UIN. So the best example for identification number is UIN or your driver license number or barcodes or all those are just identification numbers. So instead of writing down their own names or their own, even for example, think about that maybe just university wants to figure out how many students they have. And if they only saved each student as their name, then maybe there are someone who, there are someone who shared their name with others, like John Doe's, right? Something. So, and also even if they have the different name, but they have the same characteristic, right? They have the, in the same year or they have some, there are, so usually name is not that perfect to distinguish each student from others. So, okay, I'll mute it. So, oh, yeah, so to deal with this kind of problem, we just give each subject or each student with some numbers so that we can figure out that this is the unique student or this is the unique product or this is the unique persons who have some kind of ability, right? So that's the identification number. So identification numbers should be unique to distinguish each from each others. So each number represents a different person or things. And yeah, those examples are UINs, driver license number, or routing numbers in the bank, VIN for your cars, and UPC, Universal Product Code, which will be run soon, and etc. And etc. So identification number often contains one or more check digits because if you just give some numbers, then maybe some some predator or some attackers actually steal your numbers. So for example, if if you just give your driver license from 1 to some numbers, then maybe someone who didn't get the driver license but who wants to get fake driver license might just make up their numbers and show the police that, oh, it's actually that's my driver license number. And so to figure out whether the given number is correct or not, so a lot of institutions actually give some check digits to help catch data entry and data transmission errors, right? So not only preventing such a cheating, but also preventing some data transmission error because not now, but when these numbers came up in 1960s or 70s, actually computer transmission or computer telecommunication is not that correct or not that precise. So in that time, people are thinking about how to avoid such a transmission, sending some code without error, or even if the code contains error, they just want to fix it without, resending the code, then again, sending error. So that's why we need such a check digits in the universal in the identification number. So we will see what it is in the some examples into it. So before dealing with such an identification number and that check digits, what we need to know about some math is modular arithmetic. So actually, it is not difficult if you can read the time, what time is it, right? So for example, think about that our class starts at 11 a.m. and it lasts for 3 hours. Then what time is it now? 2 p.m., right? And the reason you see that it is 2 p.m. is that by taking 3 hours, your direction for hours goes to 12, 1, and 2, right? So instead of going 12, 13, and 14, and after 12, it just go back to 1, right? So that kind of arithmetic is called modular arithmetic. So in this situation, what we did is actually 11 plus 3 mod 12, right? And this is nothing but just 14 mod 12. And it is just same as the remainder of 14 divided by 12. So that's the definition of this modular arithmetic. So we just call it mod m or mod some number. And to find the number of mod n, you can find the remainder when a is divisible by m. So in general, if you see that a is some number and m is another number, so a, m are some integers, then actually a mod m is just the same as the remainder of a divided by m, right? So in this example about the clock, so 14 divided by 12 is just by taking 1 as your quotient, then it gives you 2 as your remainder, right? So that's why we get the answer as 2 p.m. Right? Okay, do you have any question on this definition or anything else? Okay, then let's try some examples. So find the following values. So 17 mod 5 is, if you to find 17 mod 5, you need to divide 17 by 5. And you can see that 5 times 3 is 15. So when you get as your remainder is 2. So the answer is 2. And 47 mod 11 is 47 divided by 11 is by multiplying 4, you can get 44. So the remainder is 3. So that's why the answer of 47 mod 11 is 3. And 53 mod 7 is that 53 divided by 7 is 7 times 7 is 49. So it gives us 4 as a remainder. So that's 4. And in case of 8 mod 13, if you divide 8 by 13, then definitely that 1 cannot be in here because 13 is exceed the 8, so it should be 0. So the remainder is 8. No, we don't care about decimals. So in the modular arithmetic, we only care about integers, not the decimal numbers. Pardon? Mhm. Yes, so just keep the inside number. So 13, so when A mod M and M is greater than A, then you can see that A is actually nothing but 0 times M plus A, right? And A is just valid remainder for this formula. So in that case, you can just write it as A, which is just remainder, right? Good question, Abid. Is it good, or do you have any other question? And then maybe you can find that from, for example, in the example 1, 17 mod 5 is 2, but 7 mod 5 is also 2, because if you just divide 7 by 5, then it is 5 times 1 plus 2. So that's why it is 2. And 12 mod 5 is also 2, right? Because 12 is 10 plus 2, but 10 is multiple of 5, so it should be 2. So 7, 20, 17, even 2, and 22. Those all have mode 5 is just 2, right? So in that case, we say that those numbers are congruent mode 5. So 2 and 7 are congruent mode 5, and 7 and 12 is also congruent mode 5, and so on, right? So that's the definition of two numbers. Oh, sorry. Two numbers as, I don't want to move this one. Okay, good. Yeah. So yeah, two numbers A and B are congruent mode M if A mod M is equal to B mod M. So A mod M is equal to B mod M. And sometimes we can, yeah, since mod M is just repeated, so we can rewrite it as A equivalent with B mod M. So you just use 3 lines as instead of the 2 lines for equality. So it means that A and B are congruent with mod M. Right? So 7 mod 5 is 2, and 12 mod 5 is 2. Well, that's why I need to write down this here. So 7 and 12 are congruent mod 5. And you can easily figure that. So in any number is equal to A mod M is equal to A minus M mod M, right? And in any number, also A plus M mod M, right? So by adding M doesn't affect about your, remainder, right? Because M is always canceled out as your quotient. So these are will be helpful for you to calculate some, larger numbers. And also you need to know that if A and B are congruent mod M, then their difference, A minus B, should be divisible by M, right? So if so to example, A and B are mod M, then it means that A is equal to some other number, A prime times some number, M, sorry, say QA times M plus some remainder, and B is also some number QB times M plus the same remainder. That's why we have A is congruent mod M, because they have the same remainder, right? So if you just taking A minus B, then what you can get is QA times M plus R minus QB times M minus R. So there R is just canceled out, right? And these two numbers are all multiple of m, so you can rewrite it as qa minus qb times m. So that's why we have that a minus b is divisible by m, right? So if two numbers are congruent mode m, then their difference is divisible by m. Also, if their difference is divisible by m, then two numbers are congruent, right? Does it make sense? Good. Okay, and then let's deal with some other examples. So determine if the following congruents are true or false. So first of all, they claim that 28 is congruent with 1 mod 9. So to see this, we need to check that it means that just 28 minus 1 is multiple of 9. But 28 minus 1 is 27, which is 3 times 9. So definitely it is multiple of 9, so it is true, right? And for second example, 29 congruent 15 mod 10, then it is the same as 29 minus 15 is 14, which means that 14 is multiple of 10, but definitely it is false, right? So 14 is multiple 2 times 7, which is not multiple of 10. And last example, 131 is congruent with 113 mod 6. And to check this, you can just taking difference 131 minus 113, and this is 18. So 18 is multiple of 6, and it is true, right? Because 6 times 3 is 18. So, oh. Right? Okay. Do you have any question on examples? Okay, and here are not came up, but one also useful fact you need to know is that if your number is multiple of two numbers, so for example, your number is a times b, and you want to find the a times b mod m, right? Then this is the same as a mod m times b mod m. So sometimes if you know that your factors of your number, then you can find this mod m business much more easier than usual. So for example, if you want to find that, let's see. Okay, so let's see that I want to find that 300 mod 7, then maybe you can just, divide 300 by 7 to get some remainder. But one another strategy you can check is that it is just 3 times 10 times 10, right? And 3 mod 7 is just 3 because 3 is just less than 7. And 10 mod 7 is also 3, right? Because 7 plus 3 is just 10. So it is the same as 7 times 3 times 3 times 3. So it is 9 times 3. But again, 9 is mod 2, 9 mod 3, 7 is 2. So this is just 2 times 3. So it is 6, right? So there are two ways to do it. So the first way is just divide 300 by 7. But if you know that they're factors, then you can just, get the mode of these factors. So factor of 10 mod 7 is 3. So you can use it to change it as 3. And also 3 times 3 is 9, and 9 mod 3 is 2. So you can also change this 9 into 2 to get the final answer, right? Yeah. So this is not in the this is not in the textbook, but it may be useful when you just calculate it. So that's why I introduce it. Okay. Then let's deal with the check digits. So I already introduced that, yeah, to use the identification number, we always give some check digits because data may contain error or maybe someone tries to fake your data. So there are some common errors. First one is called single digit error. Yeah, this is what actually you also have some experience on it. Actually, when I just typed my UIN, I always just fit some numbers with some different one. So it occurs when an incorrect digit is entered. So this is called a substitution error. And the other error is adjacent transposition, which means that actually if your identification number is 1, 2, 3, 4, that's the correct one. But maybe when you type it, actually it is a little bit difficult for this example, but when you type it, you can just write it as 1, 3, 2, 4, right? So you can just transposition of these two second digit and third digit, right? So this is incorrect one. So this is example of adjacent transposition. And the jump transposition means that the digits are separated by another, but digit and entered in reverse order. So for example, if your example is 947, but you can just rewrite it as 749, so you can just transposition 7 and 9, right? So, or in this example, in the 1, 2, 3, 4, you can type it as 4, 2, 3, 1. It's a little bit difficult for this kind of serial number, but anyway, so those are called the errors. So okay, so here example is 947 with 847. That's single digit error. And adjacent transposition error is just type two numbers with first one at second and second one as first. And jump transposition is just change two numbers in different digits, right? So those are actually common error. Not only, actually first one is common for human also, but this second one and third one is common for computers. Yeah, because I'm not expert on computer, but if you just run about some theory about the communication between on the internet, then you will know the reason why those are common. But anyway, so those are actually common error in the computer. So that's why we made some check digits to check whether your the identification number is correctly made one or not, right? And to deal with this, so let's see some examples about this identification number. So first example is sum of the digit mode 9. So it means that when you just find the money order, maybe I think that you know what the money order is, right? So when you go to your post office, then you can buy your money order instead of real money to avoid some, cash cheating or cash fake. So when you find the money order, then they give you some money order with serial number. In here is some 10-digit serial number, and the first 10 digits of serial number, actually the correct information is contained in this 9-digit, and last digit is the check digit, which should equal the sum of the first 10 digits mod 9. So for example, if you think about the sum of the first 10 digits, then you can see that 0, 4 to 0 plus 4 plus 2 plus 1 plus 3 plus 0 plus 0 plus 0 plus one more 0 plus 1. So this one is 10, this one is 1. So it is 11, right? Then 11 mod 9 is equal to 2, right? Because 11 is just 9 plus 2. So that's why we use this last digit 2 as a check digit, right? So if there is some, so it cannot capture the transposition error, right? Because if transposition error happens, then the sum of this one, doesn't change it, except when transposition error happens in here. But it captures some single digit error. So for example, maybe accidentally computer, not correct the code. So maybe accidentally you can figure out 4 as 5 as a wrong number. Then it gives us 5 plus 2 plus 1 plus 3 plus 1, which is 12. And you can see that 12 or 9 is 3, but 3 is definitely not the same as 2. So it can capture single digit errors, right? So not all of the schemes can capture all the errors, but they are some, strong for some errors, but they are weak for some other errors. So, but in case of this USPS money order, they are worried about such a single digit error. So that's why they use this sum of the digit mod 9 method, right? Do you have any question on here? Good. Okay, great. And next one is about number mod 7. So in airline ticket or UPS package and Avis or national rent car company, reserve the last digit as a check digit. And the check digit is the identification number mod 7. So maybe, for example, if you have this big number 5007125, and to make sure this is the valid number or not, so pick the last digit and then just find this 500,712 mod 7. So again, you can just divide it. Okay. Then 7 divided by, okay, I just do it here. And 7 times 7 is 49. And 7 times, here we can just use 1. Sorry. 7 times 1 is 7, 3. 7 times 5 is 35, 2. 7 times 3 is 21. 0. So what is remainder is just 2. So this is 2. But in this case, 2 is not the same as 5. So this is not a valid number, right? So maybe 5007,122 is valid, but 507125 is not valid, right? Okay, then now it is a little bit more complicated example. So it is called universal product code. So maybe you can see such a code or using barcodes in the stores or grocery stores. So in this case, actually this first part is just represent category of this item. So it is just whether your item is, food, or your item is some, electronics or something like that. So it just gives you category of the item. And this 5-digit calls you who is the manufacturer. And the other 5-digit is just denote the item itself. And the last digit 3 is just check digit. So in this case, it is a little bit, complicated. So what it means is that for each all digits, A1, 3, 5, 7, 9, and 11, you just multiply with 3. And for even numbers, you didn't multiply anything and just sum of all the numbers, including including these numbers. Then the check digit A12. So at this point, you need to also add check digit, right? So in previous example, we didn't add check digit, but in this example, in universal product code, you also need to add check digit on this number. Then A12 is just chosen so that S is multiple of 10. So S is 0 mod 10, right? So for example, in this code, so say this one as, A, and say this one as B. Then in case of A, you can check it that it is just 3 times 0 plus 2 plus 3 times 1 plus 0 plus 3 times 0 plus 0 plus 3 times 6 plus 5 plus 3 times 3 plus 7 plus 3 times 1 plus 3, right? That's as for this, first one in the left side. Then if you calculate it, then this is 0, 2, 3, 0, 0, 0. 3 times 6 is 18, 5, 9, 7, 3 plus 3. So this adding this number gives you 5. This number gives you 23. This number gives you 16. This number gives you 6. So it is 5 plus 23 plus 16 plus 6. And this number gives you 28. This number gives you 22. So it is 50, right? So, and definitely it is just 0 mod 10. Okay. So number A is the valid UPC. And you can do the same thing for this number. So actually these are our example in here. So this one, B, okay, sorry, is just you can calculate S as usual. So it is 3 times 0 plus 5 plus 3 times 1 plus 0 plus 3 times 0 plus 0 plus 3 times 0 plus 8 plus 3 times 7 plus 2. Oh, sorry, check digit here is X. Oh, I put the wrong sign, but here check digit means X. So I want to find what the check digit is. So to make this code valid, then 8 plus 3 times 3 of 7 plus 2 plus 3 times 3 plus X should be 0 mod 10, right? And if you just calculate this, then 0 plus 5 plus 3 plus these are 0 plus 8 plus 21 plus 2 plus 9 plus X. And these two number gives you 8. And this number gives you 29. And this number gives you 11 plus x. So it is 48 plus x. And it should be 0 mod 10. Means that your check digit should be 2, right? By taking x as 2, it gives you 50. So 50 mod 10 is just 0. So it makes it valid, right? So that's how you can find the check digit, yeah, when you have some original numbers, right? Two question. So how I just get to the end because in the universal product course, S mod 10 should be 0, right? But if without your, so I just put it x and 48 plus x, right? So to make this code valid, 48 plus x should be 0 mod 10, right? Okay, so okay, so let's think about that. So actually x has 10 choices, right? 0, x may be 0, x may be 1, 2, 3, 4, 5, 6, 7, 8, 9. Then your number s, if x is 0, then your number is just 48, right? And if your number x is 1, it is 49. If your number x is 2, it is 50. In case 3, it is 51, 52, 53, 54, 55, 56, and 57, right? But in all of those numbers, if you just think about S mod 10, then it is 8, 9, 0, 1, 2, 3, 4, 5, 6, 7. So 2 is already valid choice. That's how I got 2 in the last as a check digit. Does it make sense? Okay. Is it good? Good? Okay. Okay. Please ask me another if you have a question. Okay. So there are another example which is called banking. So in case of banking, the first 9 digit is about the routing number, and the other, 12 digits are for account number, and there are another check numbers here. But here we already deal with routing numbers. So in case of routing number, actually account numbers are different for each bank. So they have some different schemes for each bank, but in case of routing number, they have the all same schemes. So in case of routing number, you can just, your number should follow that by adding this weighted sum of your numbers. So R is equal to 7 times first digit, 3 times second digit, 9 times third digit, and so on, right? So, and then the A9, the last digit, equals the last digit of R. So that's how the routing number is made. So for example, in case of the sample, if you just count your R, then it is 7 times 0, because plus 3 times 4, and 9 times 4, plus 7 times 0, plus 3 times 7, 9 times 2, 7 times 3, 3 times 2. I hope this is right. So, and if you calculate this, then 0, 12, 36, 0, 21, 18, 21, 6. So 12 plus 36 is 48, and 21 plus 18 is 39, and 21 plus 6 is 27. So adding first two number, you can get 70 plus 8, 17. So it is 87 plus 27. So it is 114. So the last digit of 114 is 4. So the check digit should be 4. But in this case, yes, check digit should be 4. So valid because check digit should be 4. Right? So that's how these routine numbers are done. So in the exam, yes, some type of exam just give you such a scheme for your identification number and asks you that check whether the given number is valid or not, or just give you some number with some missing digits and just fill out that missing digits, which makes the whole number valid, right? So those are our question on homework or exam. So, okay, yes. So the next one is actually deal with such a thing. So HR representative could not read a new doctor's handwriting on her direct deposit position form. Actually, that's our program for doctors. So HR representative could tell the routing number was 314, submission number 77337. Can you determine the missing digit X for the HR representative? So the routing, so again, to deal with this, we need to find the routing number. So here R is 7 times 3 and 3 times 1 plus 9 times 4 plus 7 times some number X plus 7 times 3, 3 times 7 plus 9 times 3 plus 7 times 3 plus 3 times 7, right? So here are a lot of 7 times 3. So I just pick this 7 times 3 or 3 times 7 here. Then this is actually 21. So there are 4 21s here. So 4 times 21 plus or other numbers if it's just 3 and 36. And this is 27. So 27 plus 3 is 13. So 13 plus 36 is 36. So it is 66. So it is 84 plus 66 plus 7x. Sorry. So this is 150 plus 7x, right? So is it right? Maybe I did something wrong in calculation. So give me a second. I just check it. Oh, okay. 31477. 9 times 7. So here should be 7. Yeah. 7 times 3 and 3 times 3. Sorry. Yeah. Yeah. So, okay, my sum is wrong. Okay. Then again, still 6 times 21. And this one is 3. This one is 36. And this one is 63. This one is 33. So 3 plus 36 is 39. And adding those two numbers gives you 96, 39. So this is 39 plus 96 plus 7x. And this one is just 63. So 63 plus 96 is 159 plus 39 plus 7x. So yeah, actually my, okay, let's do it using calculator. So that's why we need calculator. So actually in my calculator, in my previous calculator, it says that this is 174. I don't know why. 37. Yeah. Ah, I know my mistake. 30 times 3 is 9, not the 37. Oh, 33. Okay, so yeah, that's my mistake. Okay, 72. So it should be 72. Yeah, 72. Then 63 plus 72 is 135 plus 39. Okay, now 174 plus 7x. Okay, now I got the exact answer I already calculated. So in this case, when x is 0, then your number r is just 174. But x is 1, then you can add just 7 from the previous one to get 181. X is 2, then 188 by adding 7 again. X is 3, then adding 7 again, you can get 195. And adding 7 again, you can get 202, 209, 216, 223, and 230, 237, right? And here the last digit is 4, 1, 8, 5, 2, 9, 6, 3, 0, and 7, right? So in this code, so here the last digit is 7, right? So the last digit of I should be the same as last digit of this 9-digit number, which is 7. But that case only happens in the last one, right? For all other ones, yeah, in case it doesn't happen. So this is the only valid case. So therefore, x should be 9. Does it make sense? So what I did is just make all possible cases of R for each x, each choice of x, then just checking that when those cases give you a valid routing number or not. And the only cases you can get as a valid routing number is when x is 9. So that's why we can conclude that x is 9. Is it good? Okay, sorry for my bad calculation. Yeah. Okay, then yeah, let's move on to the next one. So next one is about this ISBN 10. So in ISBN is actually used for distinguishing books, right? So because there are several books in the world, so we can just distinguish books by using their ISBN number. So actually ISBN 10 is some old cases. So in these days we use ISBN 13, but yeah, they are actually very similar schemes. So in this case, what we want to do is that actually there are 10 digits. So we can just do it by 10 times first digit, 9 times second digit, 8 times third digit, and so on. So the coefficient is just goes decreasing, but digit number goes increasing. So if you just do such a rated number, then this check digit, A10, is chosen so that V is divisible by 11, which means that V is 0 mod 11, right? So, but in that case, one problem is that in this case, remainder may be 10, right? Not the just from number from 0 to 9. So in case of 10, we just denote x as your 10, right? So if you are good at Latin, then actually x is the Latin number of the 10. So that's why we use x instead of this. So it is not the same as this small x, right? In this case, it is just big S or capital letter X to denote 10. So let's check the above ISBN 10 is valid. So in this case, V is 10 times 1 plus 9 times 4 plus 8 times 2 plus 7 times 9, 4 to 9, 2, 6 times 2, 5 times 0, 4 times 9, 3 times 0, 2 times 0, plus 3. So 10 plus 36 plus 16 plus 63 plus 12 plus 0 plus 36 plus 0 plus 0 plus 3. And first two number gives you 46. Also second two number gives you 79. And 12 plus 36 is 48. And plus 3. So adding first two number, 125, 51. So it is 176. And if you just deal with 176 divided by 11, then what you can get is actually it is multiple of 11, right? So it is 0 mod 11. So yes, but it is valid ISBN code. Okay. Does it make sense? Wait, do you have any other question? Yes, yeah, 0 can be last number. Yeah. Yeah. So what I mean is that in here, 0 means that actually, if you just divide it by 11, then it should be 0. If it is not the 0, then it's wrong number. So after adding, calculating this V, then you need to check that whether it is 0 divided mod 11 or not. So if it is 0 mod 11, then you're fine. But if it is not 0 mod 11, then definitely there is something wrong. So the reason it is valid is that the check digit is chosen so that V is divisible by 11, right? And so our check digit A10 in this case is 3. And by adding 3, we can get 176. But this is just multiple of 11 because 11 times 16 gives you 176. So that's why this number is valid. Good. Okay, then let's deal with some more examples. So suppose that a book you own has an ISBN number where one of the digit is unreadable, looks like 1531X 7002 6. And I want to determine which value of the x is correct for this ISBN. And to deal with this, first of all, you need to calculate this V. So, okay, I write down it here. So V is equal to 10 times 1 plus 9 times 5 plus 8 times 3, 7 times 1 plus 6 times x, because we don't know what x is, and 5 times 7 plus 6, 4 times 0, 3 times 0. Two times 2 plus 1 times 6. And this is just 10 plus 45 plus 24 plus 7 plus 6x plus 35 plus 0, 0, 4 plus 6. So 4 plus 6 is 10. And 10 plus 45 is 55. And 24 plus 7 is 31. So this is 35 plus 10. And the first two numbers, sum of first number is 86. And sum of the second number is 45. So this is 126 plus 5 plus 6x, 131 plus 6x, right? Yes, yeah, this is 131. Okay, so here when x is equal to 0, we just 131. When x is equal to 1, then you can just add 6 to get 107. And when x is 2, you can also add 6 to get 143, 149, 155. Oh, sorry. Number is too big. And 161, 167, 173, 179, 118, 5. And here I missed the number, but we also have the case x, right? When x represents the 10, but this is only allowed for check digit, right? So we don't actually care about this x, but yes, so that's why I didn't put it here. This is not valid because x is not a check digit. But anyway, so and if you just think about this as mod 11, then first of all, 131 divided by 11 is it is 10. Right, so okay. So one of the way you can see is that 121 is actually, no, it is just 11 times 11. So 131 minus 121 is 10, which means that mod 11 is 10. Then in here, instead of, dividing it again, you notice that this is nothing but just adding 6, right? So it is the same as adding 6 on this mod 10. So, and again, mod us. So it is 16 mod 11. So it is 5. And again, here by adding 0, adding 6, you can get 0. And adding 6, you can get 6. Adding 6, you can get 1 because 12 mod 11 is just 1. And adding 6, you can get 7. Adding 6, you can get 13, but 13 mod 11 is 2 because 13 is 11 plus 2, so you can get 2. And by adding 6, you can get 8. And 14 mod 11 is 3. And last 3 times plus 6 is 9. So in this case, this one is valid because, the I should be 0 mod 11, right? So in this case, your X should be 2 from this region. Does it make sense? Or do you have any question? This? Okay. Mm-hmm. Yes.
Divided by 11 was 5.
Yes, you're right. Yes.
I just want to know how you got the mod.
Oh, yeah, that's good point, Avi. So I just do it very fastly. So I will just explain it again. So in here, what I actually do to get this number 5 is that, as you said, it is just 10 per 6 mod 11, but 16 mod 11, which is 5. And the reason I do this is that A plus B mod M is the same as A mod M plus B mod M. So you can, as we did in the product, you can also do with the sum, right? So you can do mod out first and summing those remainders, or you can just doing sum first and taking the remainders, right? So that's what I actually say, but that's good point. Is there any other question? Okay, great. Then let's deal with this credit card case. So maybe some of you have already credit card, and it actually has 16 digits, but only first 15 digits is used for identifying you, and the last digit, number 16th digit, is actually used for check digit, and it is a little bit much more complicated than other numbers. So to check whether your credit card has the valid number or not, first of all, you need to get D, which is just sum of the digits in odd number positions, right? So it is just A1 plus A3 plus A5 plus blah, 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 A11 plus A13 plus A15, right? So this is D. And E is the sum of the digits in even number positions except the check digit A16. So it is A2 plus A4 plus blah, 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 A12 plus A14, not A16, right? So it already added to A14. Then T is the number of digits in the odd number position that are larger than 4. So even if it is just the same with 4, then you didn't count it. So you just compare that when A1 is greater than 4. So A1 is one of the 5, 6, 7, 8, 9. Then you can add it. But if A1 is less than or equal to 4, if A1 is 0, 1, 2, 3, 4, then you didn't add it, right? So that's the number T. Then finally, you can just make C as 2D plus E plus T plus A16. Then your A16 should be chosen so that this number, final number C, should be multiple of 10, which means that C is 0 mod 10. So let's deal with to check how to check that the given number here is varied credit number or not. So first of all, to get the D, we need to just add all odd number positions. So here D is 4 plus 2 plus 0 plus 1 plus 3 plus 5 plus 7 plus 9. And if you add all number, then 4 plus 2 is 6. And 1 plus 3 is 4. 5 plus 7 is 12. And plus 9, 6 plus 4 is just 10. So it is 10 plus 12 plus 9. So it is 22 plus 9, 31. And in case of E, we need to add all even digit numbers except the last one. So it is 1 plus 8 plus 0 plus 2 plus 4 plus 6 and 8 plus, yeah, even if it is 0, but you just stop at 8. Then if you just add everything, then what you can get is, this is 9, this is 10, this is 10, so this is 9 plus 20, so 29, right? And to get the T, you can just count how many numbers in the odd number position are greater than 4. So first one is 4, which is definitely just same but not great, so it is not counted. And second candidate is 2, so it is not counted. And third one is 0, it is not counted. 1 is definitely less than 4, it is not counted. 3 is less than 4, it is not counted. 5 is actually greater than 4, so it is counted. And 7 is also greater than 4, so it is counted. And 9 is also greater than 4, it is counted. So T is just 3, right? So there are only 3 numbers in all the digits which is greater than 4, right? Then your C is 2 times 31 plus 29 plus 3 plus the last number A16, which is just 0, right? So here, if you calculate this, then 62 plus 32 plus 0. So what you can get is 94. But in this case, 94 is 4 more 10 because 94 is just 90 plus 4 and 90 is multiple of 10, so you can just disregard it to get the remainder. The only remainder is just 4. So from this, it is neither valid correct number. Yeah, because at this point, by adding those numbers, what you can get is 4 instead of 0, right? So if we change A16 from 0 to 6, so if A16 is not 0, but if it is 6, then you need to plus 6 here, plus 6 here. Then what you can get is actually 100, right? So in that case, when you can get as a mode 10 is just 0, then it is valid, right? But the given number itself is not valid, right? Pardon? Yes, so by changing A16 as from 0 to 6, you can get the valid credit card. So it is just additional comments. But the answer is that it is not a valid credit card because it is 4 more 10 instead of 0 more 10. So yeah. Okay. Does it make sense? Are you still good? Or do you have any question? Okay, great. Bless you. Okay, so next example is some ID number, which consists of 3 digits and followed by a first check digit. So there are 4 digits here, and check digit is given by this formula, right? and you receive number 57x6. And how can you make it as a varied number? By taking some corresponding x. So to get this, A4 is 6, so 6 should be 9 times 5 plus 3 times 7 plus 8 times x mod 7, right? But again, instead of adding all of them, first of all, you can actually disregard this, the second one, right? Because 3 times 7 should be 0 mod 7, right? Because it is multiple of 7. And this number is 9 times 5 is 49. But yeah, but actually, so what we run in the first, you can see that actually this is the same as 9 mod 7 is just 2. And 5 mod 7 is just 5. And this one is disregarded. And 8 mod 7 is just 1. So it is nothing but 2 times 5 plus x mod 7. And 2 times 5 is just 10. So it is 3 plus x mod 7 because 10 mod 7 is 3. Does it make sense? Okay, do you have a question? Yes, so in the exam, I definitely always gives you such a formula that how can you find such a check digit. Then you can use the check digit to find some missing number or check whether the given number is varied or not. Yeah. So you don't need to memorize all these formulas. That's what I don't want. Okay. Okay, do you have any question on my calculation? So what I did is instead of doing adding everything and divide by 7, I just divided first. I just taking remainder for each numbers, right? Because we know that taking remainder first and adding sum or product is just same as taking product or sum first, then taking remainder, right? So they are exactly same process. But since I just don't want there is a big number because I had made a lot of miscalculation on previous one. So instead of doing that, I just calculate the remainder first. So remainder of 9 is 2. So that's why I get the 2. And remainder of 5 is 5. And remainder of 3 is 3. And remainder of 7 is 0, right? Because 7 divided by 7 is just 0. And remainder of 8 over mod 7 is just 1. And we don't know what x is, so just write x as just a number. Then when you can get is 2 times 5 plus 3 times 0, but 3 times 0 is just 0. And 1 times x is just x, right? That's how I get this number. And 2 times 5 is now 10. Okay, I'll write down 10 in here. So it is just 10 plus x mod 7. And again, I just do the taking remainder for each number. 10 mod 7 is just 7. 7 is 3, so that's why I change it to 3 plus x. So Dawson, so how I can get rid of this 3 times 7 because 7 mod 7 is just 0. Does it make sense? Okay, question? Mhm. Yes, that's the reason. So 10 just change it to 3, but yet because 10 is equal to 7 plus 3. And 3 is definitely less than 7, right? Great. So in this case, all you need to do is just put x, suppose some numbers, and figure out what the r is. So here is not r, but here is what the one you can get is. So when x is 1, then here, so here should be A4. Sorry for typo. When x is 0, then you can get 3. When x is 1, you can get 4. X is 2, you can get 5. X is 3, you can get 6. X is 4, then you can get 7, but 7 mod 7 is just 0, so it should be 0. And here, so this number should be A4 mod 0, mod 7. So, and 5, when x is 5, then it should be 1 because A mod 7 is just 1. And 6, 3 plus 6 is 9, but 9 mod 7 is 2, so it should be 2. And 3, 4, 5. So here, the only possible x should be, in this case, 3, right? Because we already know that the last digit, check digit is 6. And the only one give you just 6 is when x is 3, right? So the value of x is 6. Okay, question? Pardon?
Will it ever happen where you're working it and a few of them say 6?
Yes, so in that case, yes, there are, so in this scheme, so yeah, there are some other cases that when the two values happen. So in that case, I definitely mentioned that there is two valid choices, right? So this happens that this scheme is actually not that good scheme for doing identification number. X should be 3. So the 6 means that the last digit, the check digit is 6, right? Yes, 5736. So what we want to find is just third number, not the last number, right? Yeah. And the reason that the A4 mod 7 is 6 is that, yeah, actually this, so exactly what I found in the table below is just right-hand side of the formula. And I just compare it with the left-hand side of the formula. But left-hand side of the formula is just 6, right? So that's why we can get x is equal to 3. Does it make sense?
Wait, where did you get the numbers that you filled on the at the bottom row?
So I just filled this bottom row from this formula 3 plus x, right? Sorry for waiting time. So let's call it a day. But I just explained this. So I just get this 3 from this 3 plus x. But if you just x is 0, then you can get 3. And x is equal to 1, you can get 4. X is equal to 2, you can get 5, 6. But when x is equal to 4, then 4 plus 3 is 7. But 7 mod 7 is just 0, right? So that's how we get.
Okay, I understand. Thank you.
Thank you. Sorry for taking much more time, but okay, so see you next week. Okay, do you have any question? Good, thank you. And do you have any question in Zoom, people? Okay, then I will stop here. Thank you very much. Oh, and Leonardo, hey, can you talk with me a little bit second? Leonardo, can you hear me?
Hello. Hello.
Brother, can you hear me?
Oh yeah. Sorry, my
No
deal
problem.
wasn't working.
So can you see the chat, please?
Yes.
Could you answer it for me?
145.
Which one
Yes.
is available? So,
I believe in the email they
So
the
I-
girl in the email thread said next Monday, right?
yes, one is
Okay.
next Monday, one is this Friday. So which one is available for you?
3 to 4 or 5 on next Monday. Does that
Okay,
work for you?
next Monday is available. Then I will give you. I will see you in next Monday. So I will give you some Zoom address at that time, right?
Okay. I'm sorry about that.
No problem. No problem.
the delay.
Yeah, you are good. So, okay, thank you very much.
Thank you.